Hey, everybody. Hey, Matt. Matt, you're definitely on mute.
I am. I was just saying we ran out of time today. Like we went an hour 20 into the devs in the shed stream. We did manage to get the emojis working. It was a very simple fix, actually. What I might do, actually, maybe I'll share my screen first. But we've kind of extended it like crazy tonight. So walk everyone through it. But effectively, if I can get my screen share happening, Visual Studio Code should be up for everyone. So effectively, like we made the dumb mistake. We were like food poor, so we just whacked char set UTF-8 within the gets for the actual routes for our index file, and we did that with result as well. Whereas what we wanted was we really just wanted it within the response. So about like 10 seconds after we left, we just narrowed it down to be contained within the response, the char set. So it's a really simple fix. And now if I run the app on my side, and let me just see if I've got it working. I do. So I will stop sharing VS Code, and I'll just quickly share my browser tab. You can see, here we go. You can see a very beautiful devs in the shed, rock, paper, scissors. And you can see all the emojis now rendering rather than text. So Paul's challenge to have the emojis working again. It's all working with API Gateway and Lambda. You can see I'm not using localhost. This is an API Gateway that I'm using up in the URL here. So if I click the scissors, it redirects to next page. You chose scissors, the computer chose rock, and I got absolutely crushed by the computer. And if I do that again, I'll choose rock, computer chose rock, I tied. Choose paper, scissors, I lost against the computer. And there we go. I dominated the computer. So chose rock. And so you can see that works really well. I can just like flick back and forth and I can make a new choice. And so the app's working really, really well. There's things that we could extend it with, like having a score count to see how many times I've won or tied with the computer. Like we can do those things later. But what Paul's actually done is I actually had CSS, if you remember. I had a nice dark blue background. We had nice fonts. It was all positioned really nicely. The buttons were styled. So we had it looking a lot better within the Flask application. And Paul's done some voodoo magic, I'd call it, to get the CSS rendering with API Gateway and Lambda. So Paul, I'm just going to pop your screen on. Did you want to walk through it with everyone?
Yeah, sure. So I don't think it's like that voodoo, but I sort of thought about it and I chatted with Matt about, as we said earlier, most of the time when you're building apps with something like Flask or Chalice, you're probably going to be building it at some type of API. But we wanted to port the whole devs in the shed application across, which meant we wanted to, include that CSS. And, the first thing we thought about was, we'll just grab that CSS for our static assets and we'll go ahead and serve them out of an S3 bucket, put CloudFront in front of it. But I thought it might be fun to see how we can go ahead and serve the CSS directly out of Lambda using Chalice to go ahead and do that. So what we want it to look like is what I've got up here. So interestingly, like running it on Linux, on this instance of Linux that I've got at the moment, the font mustn't be included for the rock. So everything works except the font for the rock. So just work around that. Like it is actually working, but I just don't have that font on this machine. You can see that those emojis look different on Linux. I'll paste this into the StreamYard so you can click on it and have a look yourself. Into the chat, sorry.
Android and iPhone does work. So if you're on Windows, Android, iPhone, or Mac, it should come through fine.
Yep, so you can go ahead and you can see that will work. So if I was to go ahead, like you can just see that the application is working the same that it was for Matt. But you can see here now that there is some CSS, which is, centering this and putting that darker background on the back there. And so we'll get to the image in a minute. So I wanted to sort of show how I went ahead and shoved all of the, serving out the CSS rather than just embedding it in a template. We've been able to serve up the CSS. So if we quickly look at view the source of the page, you can see there's a style sheet, and that is to like CSS main.css there. If we click on that, then you can see that that's the CSS that's being served up from the application that's served there. Now, Chalice itself is, the way you'll typically use it is you're returning some specific response. Like if we just were to pick our index route here.
Could you open it full screen for us and zoom in maybe one?
Yeah, I don't think I can do that here. I think I have to go to, where is it?
No, you have to go into settings, if I remember correctly. File settings. And then it's within editor. And then fonts, and then make that font like 16 or something. Yeah.
Probably a shortcut key to help that out. Hopefully that's kind of a bit more readable now. But effectively what Chalice is doing is it's saying, go ahead and return some type of response. The response for those index pages is what we're rendering out with Ginger. So that is effectively what Ginger is doing is reading this index.html file, which is over here, swapping out these placeholders for the variables that we're going ahead and placing in there. So the title, devs, and the shed, that's being swapped out for there. So here's just that straight up code that's saying I want CSS, main CSS. Now that's not relative, and I did that specifically because when I want to run that locally, I don't have the /API. When I deploy it to API Gateway, because I don't have a custom domain name, I have the stage in front of it. Just interestingly, that stage is defined within the config JSON within the .chalice folder. So you can look at the API Gateway stage there if you need to. So what I did to go ahead when I was thinking about how to do this was, if you use Flask, then you have like this, this concept of like a static folder, and you can go ahead and you can serve like content directly out of a static folder. And it's the same with Node.js Express. If you have Express, you want to be able to serve assets from that application. And that probably goes back to environments where you're running on a container or on an EC2 instance, where you are serving all those assets, those static assets, from this one single largish application. But to go ahead and try and implement that within Chalice, without spending like hours looking through the docs, there might be a way to do this better, and maybe maybe there isn't, because we're probably bending the rules of what you should be doing with Chalice at this point. But basically what I did was put a route that said /CSS and then the specific file that I'm passing in. So on the URL, I'm expecting my application's URL /CSS / the CSS file, which in this case would be main.css. And if we look over here in the Chalice lib folder, I've got static CSS and then main.css, the file. The main.css file is CSS file. And what we did was I just read that file in as a variable. I replaced all the carriage return new lines in there to just be blank, so it's just nothing. Otherwise, you'll end up with like /n's littered through that file. And then the response for that is I'm just returning the value of that like variable. So it's just basically a large string, and set the content type to text.css. So it's actually like fairly easy and like pretty straightforward to go ahead and bend it to do what we want it to be able to do, which is serve up static items. And I guess it's the exact same thing that's happening with the index.html, except we're not we're not using Ginger to go ahead and swap some variables out. The next bit that we did look at for a little while was how to go ahead and serve an image out. And so you can have a look at, I effectively want to do the exact same thing. And I use that same methodology to say, with the route coming in of images and then an image file, I want to go ahead and look into my static folder, images, and then the name of that file that I want to go ahead and like render out. And this instance here, that happens to be like icon.png, which is just the avatar, nice avatar. So what I did was like go ahead and read that in, and by reading it in like this, we're reading it in as bytes. So that is coming in as like raw bytes. Now, usually when you're dealing with API Gateway and Lambda functions and serving up binary content, within your Lambda function, you base64 encode that, and you pass back a base64 encoded payload, and API Gateway will determine, based on the content type, that is something that is base64 encoded, like there's a flag that you set as well. And based on that content type, we'll then convert that back into binary on the fly for you. So you pass back base64 encoded data, API Gateway will convert that back into binary and go ahead and serve that up. So let's just have a quick look at what happens if I try and open that file. So that is it here. You can see it's definitely not working, but we'll go copy image location and I'll open a new tab, paste that in, and we can see that no matter what I try here, even if I try images icon.png, it keeps giving me back this unsupported media type, application JSON unsupported media type. So we're a little puzzled of like what was going on here, because I'm definitely telling that it's an image. We looked through the docs and I've got a couple of links we can show how that works. It looks like this should be working as expected, but it doesn't. Now there's a couple of comments that we found within the Chalice docs that basically say we can go ahead and we can set our app API binary types to */*. Now, to show what that means, I'll have a quick look in the API Gateway. So when you go ahead and you deploy your Chalice application in API Gateway, if we quickly look at the resources, we can see that all those specific routes are called out as resources here. So this isn't just a full proxying every single request all the way through and then Chalice taking care of it. It is specifically passing across all these endpoints that we are defining within our Chalice application. So Chalice itself is not just writing pure Python, but it's being, I guess, interpreted on the fly and mapping into the specific pathing and resources for gets and posts that we're doing within our API Gateway. What it does also is it sets up a whole bunch of specific binary media types. So what I've done, in theory, should go ahead and serve up the image PNG. But what happens is the API Gateway wants the requester to pass an accept header and the accept header to be image PNG. And if you pass that accept header in and make that call by using curl, for example, you will get back an image. So the image will work and come back, but your browser doesn't go ahead and do that. So it doesn't know based on an accept header, how to what content or what format it should send it back. So it just doesn't know what it's supposed to sending it back. Now, you can go ahead and basically wildcard everything to send every piece of binary back, every request back as binary by changing this. And so if I go Chalice deploy here, we're probably going to run short on time because we have to leave at 9:30 because it's gone on for a little while.
Yeah, it's true.
So that will go and update that, and that will happen in just a sec. If we reload this page, we'll see that the binary media types have been changed. So you can see now that's what it's actually gone ahead and changed there. And if I go back to that image, so now the whole application itself won't work because we've changed everything to send back binary, but the image should, but it doesn't. So icon PNG images.
Were you doing the encode in the end? Were you doing the basics before? No?
Or was I?
I thought you were at the end. You were like, no, this is right. And then you re-enabled it and then it worked.
I'll double check that. I'm not 100% sure. I changed so many things.
Your response is still coming through as the image though.
Image PNG. No, I don't think that's what it was. I think, actually, this was the basics.
Yeah, so that's what I was saying. It was, yeah.
We did get it to work, but then I changed a bunch of things and then we're cleaning up the code ready for the stream. But let's see.
I've got it working just now.
for the image.
Which image?
for
Like,
those
as
as
in,
well.
I've got the emojis working.
Nice.
Oh, the emojis, yeah, we had working.
Oh, okay.
I think if I go images, I'll just hard code this for now, and I'll do icon.png just to make sure that that's not what it was that I've messed up. Yeah. I will say that very occasionally I find that when I make these types of changes, the API Gateway will sometimes with my browser cache that response.
It caches it, yeah.
So I have seen that happen before. I'm just going to try that in a different browser. It's definitely not working at the moment. We might have to come back and revisit exactly what it is that I did, because I'm almost positive this is exactly what I did. This is opening that file, reading that in as bytes.
Mm-hmm.
So that's a byte stream, like a bunch of bytes. Then I was trying originally to base64 encode it and then pass it back out as the so the response is a base64 encoded response. But yeah, I don't know. That doesn't seem to be working anymore. So maybe I broke it again to a point where it should be working. But anyway, what it comes down to, and I'll paste in a couple of those links that we found on Chalice. So I think it was, yeah, was it this one here? So I'll paste in this link and we can have a look, because we're not the only ones that have come across this. Oops, I didn't copy and paste that properly. We weren't the only ones that came across this this specific challenge, I would say. I said that this was a whole bunch of
up, just a little bit above, actually. It kind of gives you a little more detail. So it was just a little bit more up.
There was a specific GitHub issue where it was, yeah, this is the one, issue 1501. So here's somebody else that's going through the same challenge that we were. They were saying they wanted to return a PDF file. Usually they want that all they're getting is base64 encoded instead of like bytes. And so when you have a look at what this person is doing, they're doing exactly the same thing that we're doing, except they're specifically calling out application PDF to go ahead and send that back. And they're setting their content type to application PDF as well. And the body is they're opening this PDF file, they're reading that in, and they're just sending the content directly back out. So that should be just a bunch of bytes. And so if we have a look down here, so here's where we started to have a look and say, */*, so everything as a binary type. And that will go ahead and enable you to return that. So we did definitely get images returning. Like, I don't know what I did just now to make that not work properly. And it could be, I don't know. I'll revisit that at another show or something later in the future. But what it means is the moment you change this to */*, you can no longer run the normal devs in the shed. It doesn't work anymore. It's internal server error. It'll just throw errors over and over. So that is not a really good solution at the moment. So we actually couldn't get that to work the way we had hoped to get it to work. Other than deploying two APIs, which is not, I don't think that's a great option at all. But there is some people have mentioned that there is a way to convert JSON responses back to override that binary type and send the JSON response back as a byte, like as bytes rather than like a simple object, a string. And on the fly, API Gateway will convert that back into the string. So
yeah,
this should
that's
now...
issue 1523 talks about it, actually.
Okay, so yeah. 1523 was the other one. So you could see there, as soon as I change that content type, the application loaded again. My image still won't load. I don't know what I messed up there. We won't worry about that right now. But you can sort of have a look that, where did they say?
So this one, actually, there's one where you treat this guy.
Yeah, so this guy said he'd been battling with it for 16 months. And I sort of understand, like, why. Like, we mucked around for a little while, and I sort of figured out that what was going on here. When I try and force everything to come back as binary, because I'm not returning binary anymore, it's throwing that error every single time. So, like, one of the first things I did was like, all right, take that string and I'll convert that back into like bytes, and I'll return bytes and see if it works. But that didn't quite work. However, if we were to do JSON dumps objects.encode, but by what this guy's saying, that should work. Except that the difference is we're not returning JSON. We're returning like, specific, like it's effectively just a big string, like HTML string, right? So we're probably going to have to like go ahead and look at how did it implement something like this on top of that. And from that, we'll be able to, we should be able to return both images and like text and anything we want to go ahead and return there. So yeah, it was quite interesting. And if we go back to 1501, you can see that I think down the bottom they said, so he merged in 1530. If we look at this and we look at the files changed, we can see that, so that in the actual Chalice framework, they went ahead and looked for specific like content type. That actually he added or not content types. I mean, I'd have to go and figure out what's going on here, but it's basically saying if a user does not provide a content type header, what can happen if they return a Python type instead of a response. So if I was to just return, rather than like the way we return response here, if I was just to return template or a JSON object, it should convert that for me automatically. And that's what this is looking like it is doing. That is saying, if I return like a dictionary out of Python, convert that automatically for me, and take that back from from bytes, and then pass it back as a string. So when I get that back, even though I was trying to force everything to be binary, I'm now getting an actual string coming back from API Gateway. The rest of this was all around the unit test. So there was 10 times more unit test code to make sure they were going in and addressing that. But I don't think that this specific fix will address the issue that we're facing, because we're not just talking about application JSON. We're returning, our content type is text HTML. So yeah, still a little bit of work to go to get the whole thing running out of Chalice. But I guess better than not being completely plain, and better than earlier when we just had buttons there. So it was quite an interesting little adventure going through and picking apart what Chalice does, and also going back into the part where the application itself is not just the code that's being run. The Chalice framework is looking in here and is going ahead, and these things have meaning. So we're not, like, you can see this app. This app doesn't exist here anyway. We're not importing this app. This is something that's by convention that Chalice is going. App here is Chalice, but this Chalice itself is looking at these specific values and changing infrastructure. So the infrastructure around the application. So that the code that we're writing is not just code; it is infrastructure as well. And that probably comes back to that comment that I think it was Hello Lupin said, where Chalice tends to be touching infrastructure and code in the same code base. So it can be a little confusing. So I'm starting to see why he said that was a little confusing. And this might like shake itself out once you understand and know how it's supposed to work. But I can definitely see how it's interesting that changing what I think is code in my application is actually changing some infrastructure there. So I thought that was pretty interesting.
Yeah, that was an interesting learning. Now, I know you might have to jump. That's fine. We've got a bit of an event on now. But we did have we did have Aaron actually join us too, because Aaron was really excited to bring Lizard and Spock into the mix. And so he's kind of built on top of the code base very quickly whilst we've been talking just now. Do you want to take us through what you've done, Aaron?
Yeah, sure. So, as you just said, Matt, like I've been furiously typing while Paul's been explaining. So I only just pulled this down out of Git, and I've just made the change now, and then deployed it with Chalice into my account. And so it's changed, up and running, everything in the last however many minutes Paul's been talking. So I've just commented out what was already there, so you can see. Let me just zoom in a bit so you can actually.
That beautiful like nested logic within the if statements.
Yeah, so the more you get to know me, the more you realize I hate nested if statements or
I would have made it a switch
case statements.
Oh, there we go.
Yeah, absolutely hate switch case statements. I have a bit more of a functional programming background, so when it comes to programming, I'll opt for the function over an if else nested if statements and case switch with nested if statements. I mean switch case. And only just because, from my point of view, like when working in hardware, I can actually squeeze a lot more into a small function that has an array of, say, lambdas or array of functions that I can execute without having to write out all the logic. It just saves on space. When we're in this world here, we've got all the memory in the world, so we don't need to worry about it. But it's just that background on embedded systems, so I kind of stuck with me. But what I've done is I've actually taken from what was built out in terms of choice. So the computer choice, I've added the extra Lizard and Spock. So nice. We've got rock, paper, scissors, Lizard, Spock now for the choices. And where the computer choice, so it's still doing all the same thing. I updated the HTML to add the extra 2 options to the form. And so the only thing that I've changed there is added options to the form, nothing else. Then, so we're getting the choice from the user submit through the URL form encoded body sent through, and the computer choice is random. So it's getting from that array at the top, the array of emojis, it's getting the computer choice. And then instead of going through choice equals computer choice, you tied with the computer. So same. The first bit is just if your choice and the computer choice. I could have just left it the same and got rid of the else statement here. But instead of doing this list of or, all I've got here is our outcome. It
definitely wouldn't have lasted Lizard Spock adding it in. It was already too complex. Yeah.
So this is, I'll show you the dictionary in a minute. But anyway, all we do is to a dictionary, we hand in the customer choice or the user choice and to the actual array or the dictionary, and then the computer choice to the function. And all we're doing there is looking at this. This is the dictionary. So these are all the choices. So based on the user choice, we select from the list and we execute the Lambda. We can hand in the computer choice to the printed outcome function, which again is just a single if else.
So which is like, explain to me, it's a bit of an inception, right? Running lambdas within Lambda. Like I know they're completely different things, but what's a Python Lambda for those that aren't familiar?
A Python Lambda is a generic function. So it allows us to hand in a function that will be executed later. So in this dictionary, I've got an item, which will be a Lambda or a function that can be executed later with a variable that I want to hand into that function that I execute. The actual function that I want to execute later is the print outcome function that I've written below it here. And so it wants to execute computer choice, player choice, and then my arrays. So my array of these, this is the array of what beats and the choices to lose to. This is the array of what loses to what wins. And so for a Lambda, I can hand in any number of variables here, and then I can use them to be handed into the function that I want to execute. So this Lambda will execute when I call it. So if we just quickly go back down here, this bit here is executing the Lambda. So basically from the outcomes, I could still pull the choice. If I didn't have this, it would just be assigning that Lambda to that outcome. And then I could say outcome, if I could spell outcome, and then do the execution like that. Same way. So it's just assigning the variable, but we want to actually assign the result to outcome so that we don't break everything. So computer choice just handed straight through to the function. So you could essentially just say that we've just done the case statement or the switch statement as a dictionary, and then the nested if else statement is then handled by a simple if the computer choice is in the choice lose array, so that's that array, then the computer choice beats the player choice. But if the computer choice is in the choice beats array, other way around, that's loses to choice beats, then yes, player choice beats computer choice. So it's basically simplified the logic. We only have to do it once, and then we can hand in all of the options, for every single different combination. So as we were to get more complex, if we wanted to add 5 more different things that this can be, that can be, this can be that, then we can just extend the arrays without having to add additional nested statements, and we can still keep our basic logic.
Yeah,
and let's run it. So I actually did have the console running. So I just did a deploy to my account. So you can see you got Rock. The emoji for Rock isn't quite working or rendering, but
yeah,
Rock,
you're on
paper,
Linux
scissors,
as well, aren't you? Yeah.
Lizard, Spock. I am on Linux. Yep. So if we hit Lizard, we can say yes, Lizard beats paper, because obviously Lizard eats paper.
Mhm.
We can try again. Let's go Spock. Yes, Spock beats Lizard, but Spock beats scissors because Spock destroys scissors. And then the original ones. So we got paper beats Rock. Yeah, but if we get paper should beat, okay, paper's a draw. Paper will beat Spock if we eventually just
Yeah,
draw.
come on, Python.random. Yeah.
Wait for a few seconds. We get a couple of extra ticks and then select. All right, so scissors beats paper. Draw. Lizard beats
here we go.
paper again, but you get the idea. So there we go. Paper beats Spock. We've disproved Spock. So there you go. So we've got the whole rock, paper, scissors, Lizard, Spock, all the actual the different choices by managing it through some basic simple arrays. So these beat that, these beat that, these beat that, simple, and this is what the user chooses. And then if you wanted to look at, so I wrote this logic in a class structure a couple of weeks back when I first learned Python. And the way I did it there is I didn't even hand in any other Lambda functions. Basically, it was even more simplified. It's just the 2 arrays because the actual what do you call it? There we go. The computer choice and the user choice was stored within the class. So it's a variable within the class. So I didn't have to pull it in. It's basically when the user chooses, it stores it to the class. When the computer chooses, it stores it into the variable in the class. And then all I have to do is call the function with this beats that, and then just check against the choices that were already selected. And that's it. Simple as that. But I think it looks way better when it's emojis and when it's actually when it's served out. It's very cool.
Yeah, that's it. We can combine this with Paul's CSS, maybe get some images working. If we wanted to continue it, we could put a score in as well. But there's heaps of stuff that we could do. So thanks for taking us through that, Aaron, and thanks, Paul, as well, for extending on my code. What I'm going to do is I'm just going to put the link up for Chalice. So I would recommend people check it out. AWS SAM is fantastic. You've got serverless framework. But if you work exclusively in Python and you're used to Flask, Chalice could be a really good option, and it's really fast to get up and running very quickly. And as you saw, we ported this morning a Flask application to Chalice, and it took us around 40 or 50 minutes. So with that being said, we've all got to jump on and watch another colleague on a live stream. So we're going to leave this one and jump onto another live stream in a second. But yeah, thanks for watching, everyone. Catch you guys.